let's talk about chemistry 1125 and problem 44 on page V. And one of the challenging new things on this problem is it talks about figuring out the theoretical yield and the percent yield. If you read this problem with me, notice it says, what is the percent yield if 200 grams of barium react with oxygen to produce 179 grams of barium oxide in the following unbalanced equation? So I want you to, first of all, balance the equation and then convert the 200 grams of barium into moles. And you know how to do that. So I want you to stop the camera right now, stop the video, and do that calculation before you move on to the next screen, okay? Because I want you to have the answer and compare it to what we come up with and not copy my answer, all right? Come on, turn off the video and do this problem on your own first. All right, I hope that you got the same answer here, 2 moles of barium, and then that produces 2 moles of barium oxide. So they gave us 200 grams of barium, and we have to convert that to moles. So we know that 1 mole of barium, and we just looked this up on the periodic table, is 137.33 grams. And so if we take the 200 and divide by that, we end up with 1.456 moles of barium. And again, you should have done this all on your own, and hopefully you came up with the same answer. If you're off by just a little bit here in the last digit, that's fine. So the question is, how many moles will we get of barium oxide? Well, notice the ratio here is just 2 to 2. So if I have the 1.456 moles of barium, then that means I'm going to produce 1.456 moles of the barium oxide. So if it's 2 to 2, 1 to 1, 1.456 will produce 1.456. All right, so now that we know the number of moles of barium oxide, let's go one more step. I can take the number of grams in 1 mole of barium and number of grams in 1 mole of oxygen and multiply, or add those together, multiply that times the 1.456 moles, and I get 223.3 grams of barium oxide that are produced. Okay, so again, I want you to do that math yourself and prove to yourself that you get this same number, 223.3, by adding barium plus oxygen, multiply it times the number of moles right here, and then once you get this number, that's how many grams of barium oxide we expect. Okay, so that's called the theoretical yield. That's what we expected to get. But then the problem tells us that we actually got 179 grams. So we're going to use that as the actual. And when you take what you actually got in the experiment divided by what you predicted or expected you would get by applying the theory of chemistry, you get a decimal number, okay? And then you multiply that decimal number times 100 to convert it to a percent, and that is your decimal percent, okay? So the actual divided by the theoretical or expected gives you a decimal times 100, and that gives you a percent answer. All right, hopefully that one makes a little more sense. I have good news for you. There are none like this on the self-test or PACE test. But it'd be good to be exposed to and understand how to solve this.